Hello, class. We're about to start the last two sections for this week, which is 5.2 and 5.3. Now, 5.2 starts on page 505 through 510, problems 1 through 11 odd. And then section 5.3 is pages 516 to 518, 1 through 5 odd. Now, we will go through these like we went through all of the rest. I would do a few problems that you all must copy and do, and then also the remaining problems as well that you would need to turn in. So, with that being said, the first thing I would like for you to do is go to your textbook and turn to page 504 before we get to page 505. And I want you to look at the bottom of the page. This is the summary activity. So I want to go over a couple of these summary points before we actually get into the lesson. Okay, it says here is functions defined by equations of the form f of x is equal to k divided by x to the n, where k is a non-zero real number, have the following properties. The domain consists of all real numbers except 0. Number 2, the graph of f has the following general shape, where k is greater than 0, so that means k is a positive number, and n is an even integer. So that means, even is 2, 4, 6, 8. So they're talking about the exponent being an even integer. And you should get this shape here where k is greater than 0 and n is an even integer. Now, when k is greater than 0 and n is an odd integer, you should get this graph here. And then where k is less than 0, meaning a negative number, and n is an even integer, then you will have this graph here. Now, if you notice in A and C, they're reflections of each other. Well, they're actually they are reflections of each other, because if you fold them, and then they would lay right on top of each other. So here is basically the same thing. They're basically reflections of each other, where k is less than 0 and n is an odd integer. So basically A and C are reflections of each other, and B and D are reflections of each other as well. Now we come here to the top of page 505. Now it says the vertical asymptote is the vertical line where x equals 0. The horizontal asymptote is the horizontal line where y is equal to 0. There are no vertical or horizontal intercepts. So basically what number 5 is telling you is that this graph will not hit the x or y axis at all. Number 6, there is no maximum or minimum function value, meaning that they go on forever, no max or minimum point, and that means that they are not parabolas either. The function f is not continuous at x equals 0. That means that it would not cross that x equals 0. It won't continue. Okay, functions defined by y equals k over x to the n are called inverse variation functions, in which y is said to vary inversely as the nth power of x. K is called the constant of variation or constant of proportionality. Now we're going to get to that in some of these upcoming problems. So now we look here at problem number 1. It says doctors sometimes use a patient's body mass index to determine whether the patient should lose weight. The model for the body mass index B is the formula. B is equal to 703W over H squared, where W is weight in pounds and H is height in inches. Now it says, what is your body mass index? So basically, let's go with our body mass index. And this will, of course, vary according to your weight. So let's just say, for argument's sake, that Mr. Gibson weighs 221 pounds. Let's make it a different type of number. So 221 pounds for the W. And then for the height, let's say Mr. Gibson's height is 5 feet 10 inches. Okay, now we run into one little problem here as far as the H is concerned. H is supposed to be in inches. So we would have to take this 5 feet 10 inches and convert it to just inches. Now we know it's 12 inches in a foot, so we would take 12 times 5, which would give us 60 inches, plus the 10 inches we already had, so that'll be 70 inches. So here the height is 70 inches. Now we could take our formula. We have B is equal to 703 times 221 divided by 70, and that'll be 70 squared. So we could take our calculator. All right, so we would take 703, do the division here, then times, let's see, 221. That'll be divided by 70 to the second power. And that'll give us the body mass index. If we round it to 2 decimal places, well, we could say B is equal to be 31 point, see, I didn't look at that, 31.71. So 31.71. Okay. So it says B, suppose your friend weighs 170 pounds. Substitute this value into the body mass index formula to obtain an equation for B in terms of height. All right. Let us see here. So what they want us to do here for B, they want us to take this formula and they want us to substitute in for all of the values we can substitute in, which would basically mean we won't know the BMI or we won't know the height, because all we have here is the weight. So it'll be B is equal to 703 times 170 all over 8 squared. Okay, so we can put that in our calculator. So 703 times 170, that'll be 119,510 all over 8 squared. So it'll be B is equal to 119,510 divided by 8 squared. Okay, now we look here at C. It says, what is the practical domain of the body mass index function in part B? Okay. Well, let's take a quick look. Okay. Now remember, with the practical domain, we're talking about things that are not anomalies or things that seem unrealistic. So if you look here, if we're going according to B, we were missing the height. So thinking about this, friends, we're all adults here. We know typically most of the people that we know are not going to be under 3 feet. So we could say 36, so we could have picked a higher number. And since it's using inches, 3 feet is 36 inches. So we know this height is going to be in between 3 feet till about 7 feet, which would be 84 inches. So it's going to be someone that's taller than 3 feet, but less than 7 feet on average. Now, of course, we know that sometimes you know people that's shorter than that or taller than that, but just for the sake of this problem, we picked out these values. Okay, now, if we look here at D, now D, it says, complete the following table using a formula for the body mass index of a 170-pound person. Okay, so basically what they want us to do is to find out what B is equal to. So I want to take the calculator and we could actually use the calculator to calculate these values. So if we go here, we would have the formula, and I'm going to do a little substitution here. I'm going to make by and hx. So we can have y is equal to, we know our numerator would be that 119,510 divided by x squared. Okay, this would be our formula here because we already substituted in for w. So now we can hit this little wheel here, and we can hit this here to convert it to a table. Now what we're going to do, we're going to put in the values here for what would be h. H is actually our x. So we're going to put these values in x. So we would have 60, 64, 68, 72, 76, and also 80. Now, if we rounded these to one decimal place, so for 60, it'd be 33.2. So it'd be 33.2 you would put here. For 64, it'd be 29.2. For 68, it'd be 25.8. 72, it'd be 23.1. 76, it'd be 20.7. And then 80, it'd be 18.7. That would be their body mass index. Now, we go on over to the next page. Now we come here to E. It says sketch a graph of the function defined by b equals 119,510 h divided by h squared. Use the data values in part D to help you determine an approximately scaled axis. Okay, so first of all, when we look back here, we have this here. If you look at this scale here, according to your textbook, you can actually go by fives, and then this will end up right here. If you go with by fives, this would be 0, 5, 10, 15, 20, and so on. And then this will end up being 80, and this last part here will be 85 for your H. Okay, so that will cover everything that we have here. Now, for your B, which is our Y value down the side, you notice here the lowest value we have here is a little over 18.5, 18.7, and then it'll go up to like 33.2. So what we could do here, we can actually go by, let me see. So we got up here with the body mass index. I guess we could go a little higher. So what we could do is we could go everything by, let's go by tens. So it'd be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. So if we go by tens here, that will cover everything here. Now, let's take a look. I could zero in. This is basically what the graph would look like, or maybe I should expand this out. This is basically what the graph would end up looking like. But we know that we would not do this side here because we won't be dealing with any negative values. So we could adjust the scale, like I showed you all on occasion. Like I said, with X, we could go from 0 to about 85. And then here for the Y value, we can go from 0 to about, we could say 100. That wouldn't hurt. All right. So now as you see here, we can see the graph a little better. We don't have to worry about this side, but this side here, we can see it quite well. And then you would draw your graph accordingly. Okay, so now that we took care of E, now we need to go to F. It says, what happens to the body mass index as height increases? Does this make sense in the context of the situation? All right. Let's go back here. Now they said as height increases, what happens to the body mass index? Now we know height is in our denominator. Whenever your denominator increases, that means the overall answer will decrease. So what we would need to do here, we could write this out for F and state that body mass index will decrease as height increases. Okay, now we're asked the question here further in F. It says, does this make sense in context of the situation? We could put it makes sense because two people of the same weight but different heights look different. Typically, the taller person looks skinnier. And that's basically it. All right, now we come here to G. G says it is recommended that a person's body, wait a minute, let me do this here. It is recommended that a person's body mass index be between 19 and 25. Use the graph and the trace key on your calculator to approximate the values of H for which a 170 pound person has a BMI between 19 and 25. Okay, so we're going to write out that formula again. B is equal to, now remember our numerator was this 119,510 because we're still doing this with the person that was 170 pounds over the height squared. Now what they want us to do, they want us to get a value that has the BMI or our Y value according to Desmos calculator. Our Y value between 19 and 25. So what we could do here, we could go back to our calculator and we could scroll here. Because remember, we want to get it. I should be able to just click on this graph here. Well, it's not letting me do it on the graph. All right. So what we're trying to do here, we're trying to get it where the lowest value is 19 or a little, well, 19 for the BMI all the way up to 25. Now, if we look here, okay, class, I took the liberty of doing this. I put the equation back in. This was the table just to show the points that we had earlier, but we need to put the equation back in order to slide up and down the graph here. So remember, we want to get it where our Y value will end up being 19 and our x and our y value be 19 and 25 to give us the values to go in between. Now, if we look here, I got it down just a little. Okay, this is about, let me see if I can get it down just a little lower. Okay, so we got our y value, so that's about 79.3. So let me just write that down. 79.3 is what would get us our 25. Now, I mean our 19. And now we want to get it where our 25 is. Let's see. So it's about 69.1. All right. So now that we have our values here, so basically our H is going to be greater than 69.1 but less than 79.3. So that is the values it has to be in between in order to get that 19 BMI or 25 BMI. Okay, now G. It is recommended that a person's body mass index be between 19 and 25. Use the graph and the trace key on your calculator to approximate the values of H, for which 100%. We basically did that already. So we did that already. All right. So now we're going to move on to problem number 3. It says match the following functions with the accompanying graphs. Okay, now we need to go back, and I would just tell you to turn back to page, it'll be 504. But what you're looking at is that formula f of x is equal to k over x to the n. Now remember, when we talked about this, it was told to us with the graphs that when k is greater than 0 and n is an even integer, so k, if you look at the I here, it has f of x is equal to 10 over x to the 4th. Now we know this 10 represents k. That means that k is greater than 0. And then our exponent here is positive 4, which it would happen to be an even integer as well. So basically, our number 1 here should go where b is. So number 1 will go with b. So we would just put that in your textbook. You would go right over here, put B, and then you would graph what it's supposed to look like. So you'll put the 1 here next to the B, then you'll graph what it looks like. Now we go here to number 2. Our K is greater than 10, but our N is a positive 5, so it's an odd integer. So if you look here, the one that most represents that is C, and that would be number 2. So you'll put 2 for C, and then, well, it's already graphed. You'll put in 2 for C. Now we go here to 3. We have H of X. Now if you notice here, your K is less than 0. So we know that's negative. So then we look here at the exponent on the variable. The exponent on the variable is odd. And the one that fits this the best is A. So 3 would be with A. Now number 4, we had negative 1 for K. We know that K is less than 0. And then we have an even exponent on the X. So that would end up giving us D. So number 4 would be D. And that's basically it for number 3. Now, I think I want to skip number 5 and go to, let me see, number 7. Okay, number 7. It says, complete the following tables of ordered pairs for a given inverse variations. Determine the constant of variation and write the equation that is represented by the table. It says y varies inversely as x. So for number 7, y varies inversely as x. So that would be y is equal to k over x. Now what we need to do, we want to solve for k so we could get our formula. Then we'll be able to solve this. So if we look here, we already have one ordered pair that's stated there, that 1, 2. So 2 is y and 1 is x. Now we know k divided by 1 would just give us k. So 2 is equal to k. So our formula would be y equals 2 over x. Now all we have to do is put in these values. So I'm going to do the first value here. So you have y is equal to 2 divided by your x is 1/2. This is the same thing as saying 2 divided by 1/2, which is 2 times 2, which is 4. So in your y value here would be 4. So it'd be 1/2 4. Now we go through with the same formula. And this time we'll substitute in 2 for x. So your y would be 1. And then finally with the 6, we have y equals 2 divided by 6, which will give us 1/3. And that will be it for A. Now, we look here at B. B says y varies inversely as x to the 3rd power. So we'll have y is equal to k over x cubed. All right, so we have two values that was given to us. So we have y is equal to 1, and then x is equal to 2. So that'll be 2 to the 3rd power. So it'll be 1 is equal to k over 8. Now we need to get k by itself. We'll multiply each side by 8, and 8 is equal to k. So our new formula would be y is equal to 8 over x cubed. That is the formula that we would use. Now we will go through and substitute these values in. So first we would do the 1/2. So we have y is equal to 8 divided by 1/2 to the 3rd power. Now 1/2 to the 3rd power is actually 1/8. Because 1/2 times 1/2 times 1/2 is 1/8. So this would be 8 divided by 1/8, which would be 8 times 8, which is 64. So your 1/2, your y value would be 64. Now, we would take this same formula, but this time x is 1. So it would be 1 to the 3rd power, which we know is 1. So y is equal to 8. So it would be 1/8. Now we go here to 6. Same formula. Same exact formula. So we have y is equal to 8 over 6 to the 3rd power. So it'd be 8 over 6 to the 3rd power is 216. Now 8 goes into 216 evenly. This would be 1 over 27. So your y value would be 1 over 27. Okay, now we're going to move on to problem number 9, which would be the last problem we do from this section. So problem number 9. It says the amount of current I in amps in a circuit varies inversely as the resistance R in ohms. A circuit containing a resistance of 10 ohms has a current of 12 amperes. Determine the current in the circuit containing the resistance of 15 ohms. Okay, so they tell us that the circuit varies inversely as the resistance. So what we would have is I is equal to K over R. Remember, this is problem number 9. So it'd be I is equal to K over R. So now, they tell us here that a circuit containing a resistance of 10 ohms has a current of 12 amperage. Okay, so they tell us what the resistance is and they tell us what the current is. The current is 12 and the resistance is 10. So we do this so we can find out what K is equal to. So in order to get K by itself, we'll multiply each side by 10, and that'll be 120 is equal to K. So we will have I is equal to 120 divided by R. So that is the formula that we would use. Now, they says determine the current in a circuit containing a resistance of 15 ohms. So our next step, we have our equation. Now we're going to go through here and we're going to solve this. We know we have 120 as our constant, and we're given a resistance, which we're told is 15. So we will have the I is equal to 120 over 15, which would give us the intensity, the amount of the current, I, which would give us 8 amps. And that would be our final answer. Now, we are done with section 5.2. We're about to move to section 5.3. Let's take a look back at the syllabus. So section 5.3 is on pages 516 to 518. So let's go there. Okay, class. We're on page 516, and we're going to look at the summary activity. Says number 1, a function q defined by an equation of the form q of x is equal to k over g of x, where k is any non-zero constant and g of x is a polynomial with degree greater than or equal to 1 and g of x is not equal to 0, belongs to a family of functions known as rational functions. Examples include f of x equals 10 over x squared, g of x equals 10 over x minus 4, and h of x is equal to negative 5 over 2x plus 6. Now we come here to 2. The domain of Q is the set of all real numbers except those values of the input x such that g of x is equal to 0. If g of a is equal to 0, then x equals a is a vertical asymptote. Q of x equals k over g of x, where k is not equal to 0. The horizontal asymptote is the x-axis, where y is equal to 0. All right, now, since we're only supposed to do 1 through 5 odd, I'm just going to do problem number 3. So you would be responsible not only for the number 3 that I'm doing, but also problems 1 and 5. And again, if you have any questions, you could contact me. We can meet at office hours and we could go over some more of these problems if you need to. Okay, so now we go here. It says without graphing, determine the domain of each of the following functions, then determine the equation of the vertical asymptote for each function. Verify your answers using your graphing calculator. Okay, so first of all, let's look at A. So we have 3a, which is f of x is equal to 6 over x minus 7. All right, now, if you notice here, if our denominator becomes 0, because what we're trying to find out is basically what the domain cannot equal. We basically could look at this and see that the domain, this x value would never be 7 because we cannot have this denominator become 0. It could be any other number but 0. So x here cannot equal 7. So basically our domain is all real numbers except x equals 7. That is our domain. Now, they didn't ask us for the range, but our vertical asymptote will also be x equals 7, because our line would not cross it where x equals 7. Okay, so now we go to B. We have g of x is equal to 20 over 25 minus x. Now we know if we make this denominator equal 0, this will be undefined. So we know x cannot equal 25. So our domain is all real numbers except where x is equal to 25. And then our vertical asymptote, I'm going to abbreviate that, will actually be x equals 25, because we know our graph would not cross that value. Now we're going to go to C. So we have h of x is equal to 3 over 2x minus 10. Now, again, this denominator cannot equal 0. So we could go off to the side and set 2x minus 10 equals 0 and then solve. We'll add 10 on both sides. 2x equals 10. Divide each side by 2 and x is 5. So we know x cannot equal 5. So our domain, I'll abbreviate that. Our domain is all real numbers except x equals 5. And our vertical asymptote is x equals 5, because we know our graph is not going to cross at that point. Okay, now we go here to D. So D, we have f of x is equal to 13 all over 0.5x minus 7. So now we will set this equal to 0, that denominator, and we can add 7 to both sides. So we have 0.5x equals 7. We divide each side by 0.5. Now we know 0.5 is really 1/2. So this would be x is equal to, this is the same as saying 7 divided by 1/2. And 7 divided by 1/2 is 7 times 2, which is 14. So basically, x, in this case, x cannot equal to 14. So our domain are all real numbers except x equals 14. And our vertical asymptote is x equals 14. Okay, last but not least, we will have E. E, we have g of x, and that's equal to -4 over 2x plus 5. Now we can set our denominator 2x plus 5 equals 0. And then solve. Subtract 5 on both sides. 2x equals -5. Divide each side by 2, and x is equal to a -5/2. So we know x is not going to be equal to a -5/2. So our domain, all real numbers except x equals -5/2. And our vertical asymptote is x equals -5/2. Now, in the back of the book, you may see they may have written this fraction as a decimal, so -5/2 and -2.5 would be the same. Now, if you want to take a look at this in your calculator, let me pull up the calculator. So I'm going to do one of the problems here. Let's get rid of all of this. All right, so the first problem I'll do is D, that y is equal to, what's that, 13 divided by 0.5x minus 7. All right. We want to prove that this is not going to cross over at x equals 14. So if we go here on the x-axis, well, let me do this. Better if I do it like this here. Zero. Zero to, see if I do 20. All right, 0 to 20. I could do, let me see how this will look. Okay, each one of these are going by, looks like, okay, this looks better. Okay, when you look at this graph here, it comes very, very close to 14, but it doesn't quite cross it. So it'll keep going on and on. We'll pull it down. So I just keep pulling it down. And see, it just keeps going on and on. I could just keep going all the way up here. And you notice here, it never hits 14. It gets very close, but never hits 14. And the same for this graph here. I could go down as far as I want to go, but it still would not hit 14. It'll get very, very close, but it won't hit it. So that is a quick example of how it would look in your calculator. And as you see here, there's an imaginary line here that's separating both of these that you cannot see. So that's basically a visual representation of the vertical asymptote and the domain being basically all the real number x values except for 14. And that works for all of the rest of the problems. Now we're done with both sections 5.3 and 5.4. Again, if you have any other questions, feel free to contact me, and have a wonderful day.